In this video, we're gonna talk about constructing a histogram for binomial random variable using histogram or table to find probabilities. And also we're gonna talk about mean and variance and standard deviation of the binomial probability distribution. So here's a probability table or a sequence of 3 binomial trials, and then with a probability of success 0.6. We calculated, these are all possible outcomes for a number of successes. We could have 0 in 3 successes, 1 in 3, 2 in 3, or 3 in 3. And we calculated the corresponding probabilities. If you want to see how we did it, I showed it in a previous video, so check it out. So we have this table, and now let's construct our probability distribution histogram. On the x-axis, we have our random variable x. The values are 0, 1, 2, and 3. And then we're going to create a bar. Each bar is going to go up to the value of the corresponding probability. So my highest probability is 0.432. So I'm made sure I have 0.4 here on the y-axis. Y-axis is probability. And let's do it. So for probability of 0 successes, we have 0.064. I will put my ruler for reference. So it's 0.064. So it's about 64 is about here. So this is going to be the height of my bar. The next one is 0.288. I mean 0.2, yeah, 0.2. So 0.2 is here, 0.2, 0.5678. That's about here. And we're going to finish it in a similar manner. And here we have our histogram completed. And before we move on to use this histogram, using this histogram to solve for probabilities, I want to talk about the shape of this probability histogram. So the shape depends on the probability value. 0.6 is what we have here. Now, when your probability is 0.5, we're going to have a perfectly symmetrical normal distribution. Now for the probability of 0.25, we're going to have the distribution that's skewed to the right. And for a probability of 0.75, for example, we see that it's skewed to the left. So yeah, that's how the shape depends on the probability of success. Okay, so now let's use this histogram to find the probability of x being greater or equal to 2. So greater or equal, greater means on the right side, right? So we're gonna include our bar above 3. So to the right of 2, but also since we have an equal sign there, that means 2 is included as well. So we're gonna include this bar as well. Now, where those corresponding probabilities in the probability distribution? Well, they're here. Okay, so these are the events of 2 or 3 successes. And the probability of that number of successes is greater or equal to 2 would be, we're going to add these two probabilities, 0.432 and 0.216. And that will equal to 0.648. So the probability that the number of successes is greater or equal to 2, or in other words, 2 or 3, is 0.648. All right, so the next question is compute the mean, variance, and standard deviation of this probability distribution. Now, we could do it in the same way we did before, just multiply x times p of x, add them up to find the mean, and you know the process for finding the mean and the variance. But in case of a binomial probability distribution or Bernoulli trials, our formulas do simplify a little bit, okay? Actually a lot. And that's why we like to use this probability distribution, because it's way easier to compute mean and standard deviation. For the mean, you just multiply your n, the number of Bernoulli trials, and by the probability of success, which is the same for each trial, right? And then for the variance, you multiply same thing, but there is another factor q, and you get your variance. And for standard deviation, you take a square root of this product. That's it. So let's, so for this probability distribution, our n is 3, p is 0.6. So the mean is going to be, mean of x is 3 times 0.6, and that's going to be 1.8. Okay, for the variance, we're going to do 3 times 0.06 times the probability of failure, q, right? And we know it's 0.4, 1 minus 0.6. And what is that equal to? Well, that is equal to 0.72. And finally, if we want to find the standard deviation, we're going to take a square root of 0.72, and that's going to be equal to, it is actually a long decimal, 0.848528137, but I'm going to round it to 4 decimal places, so it's going to be 0.4845. Okay, so that's those are the formulas. That's how you're gonna find your mean and standard deviation of the binomial distribution, and proceed to the next video for more applications.